I'm Hal.
I'm Mary.
Today we're going to be measuring the densities of these two bowling balls.
I have the 12-pound ball.
This one is about 16 pounds. Now we're ready to measure the mass of the two balls. This is the heavier one of the two. We put rubber stoppers into the finger holes so that when we calculate the volume of the sphere, it'll be easier than calculating the volume of a sphere with the holes in it. So it just makes the calculation simpler. We've already compensated for the mass of this rubber ring on the bottom, which is there just to prevent the balls from rolling off of the pan of the balance. Now I'm going to add mass to the back of the balance to compensate for the mass on the front. That's 1 kilogram, 2 kilograms, 3, 4, 5, 6, and 7 kilograms. In addition to the 7 kilograms, we have 295 grams. Be sure you've recorded the mass of that first ball, 7,295 grams, in your activity sheet because you'll need it later on. Now we'll determine the mass of the second ball, the lighter of the two. Put it on the balance and add 1 kilogram, 2 kilograms, 3, 4, 5 kilograms. So the mass would be 5,300 grams. You should record this in your activity sheet as well.
We have just calculated the mass of the balls, and now in order to find the density, we need to know the volume. And we're going to do this by finding the circumference. Or we could do it by radius or diameter, but that's a little more difficult. Here's my friend Barney. Oh, he's helping. Okay, so we're going to take the circumference, and I've got a measuring tape in inches. So here we go. It is 27 inches, and that's great. Regulation bowling balls have to be 27, really close to 27 inches in circumference. And from the circumference, we can find the volume. You've just seen me measure the circumference of a bowling ball at 27 inches. Now your task is to take the 27 inches and convert it to the metric system on your activity sheet. After you find the centimeters, continue on to find the volume of a bowling ball.
Now we've measured both the mass and the volume of the bowling balls. And we're ready to calculate the density, which we want to do in the metric system in grams per cubic centimeter. We're at the density testing facility that we've had constructed especially for this purpose. This is the first bowling ball, the heavier one. I'm going to toss it, we'll see what happens.
This is the lighter one.
The ball is on the bottom and it's slowly rolling toward the drain. There it goes.
Okay, here's the lighter ball. Way over here.
It's definitely floating. It's coming up. Science rules. These measurements on bowling balls have been kind of fun and interesting, but what relationship do they bear to hands-on plastics kit, Mary?
We get 6 recycled resins in the kit, and the first thing we do is we put the resins in water to see if they float or sink. So we're comparing the 6 plastics to 1 gram per cubic centimeter. And once we do that, we can put it in other solutions or do other tests in order to identify the plastics.
So the plastics that sink in water have densities that are like the heavy bowling ball, and the ones that float are like the plastic, like the bowling ball that floats. like the plastic foot.
Now I'm going to ask the man on the street, what is the density of a bowling ball? And I think they're going to be really, really wrong. What do you think?
I'm Hal.
I'm Mary.
Today we're going to be measuring the densities of these two bowling balls.
I have the 12-pound ball.
This one is about 16 pounds. Now we're